Hello everyone, and today we will create the remaining base support of our tower that we created in the last video. And we are done with the guardrails and the base of the tower, and now we need to create the support of the base. So without wasting any time further, let's continue with our tower base. From the last video we have this we have created this in the last video. Now I need to create the base support that would support the weight of this to the ground, and we will create each support planks and we will combine them together to create the whole support. So now, to create the support, first we need to create the support base on which the supports will be attached. So to create that, first I need to convert this into a single primitive circular primitive ring. So from that we can go to here, connectivity. When I toggle the display on, you can see we have our base mesh. I need to separate this, and today I want to show you something. In the last video we have created our group expression node, and we have told Houdini that we want the class equals to the max in this group. That means we have a max value. We had a max value in the last class, right? So, and that max value was like changeable. So if you increase the number of points of the line, the max value would increase. But we have already told Houdini that if the max value increases, that we have a total number of classes and the topmost class is our max value. In the last video we have just covered everything, and in this video we will also separate this primitive circular ring. But in this video we need a minimum value. What I mean by minimum value, we don't need to tell Houdini that don't need to give this something like this expression. We don't need to give this. We just want to tell Houdini that we want to separate our class, which class at the rate class equals to 0, and delete non-selected. Now we have selected this. Now I want to tell you something, that if we change the number of points in this line, class 0 will always be this ground one. It always counts from the ground to the top. So if we increase the point value, the top value will change, but your class value will always be the same because it starts from 0 to, you can take this to any number, but it will always start from 0. So we are here. When we say I want class, not class 0 in this group, that means I want to blast everything but class 0. And if you increase the number of points, class 0 will always be the last primitive ring. We don't need to give any expression. We have just selected our class 0. And now I need to extrude this to create the base of the base support. And what I mean by that, just follow me. First I would poly extrude this circular ring, and when we extrude this inwards, right, when we extrude this inwards, it is we have this we have this, what's the word, we have this primitive, we have this mesh, we have this geo, we have this uh, I don't know what, I can't remember what's the exact word, but you get the gist, right? So we have this structure. Let's say -1 is okay. And you see, these primitives are not parallel to the base. We need them exactly like parallel to the base, like straight. They are like inwards right now. So what we can do, we can insert this so we can have the length of these shorten up. And what I mean by that, you would see here. See, now the bottom part, we only need the bottom part, so we don't need to push everything up. We just need to separate the bottom part for our base. And if you give this, you can see it is getting parallel the middle, the lower part, and right now it's perfect for our next step. And I will show you this poly extrude by this box, and I will tell you two main things. Go to poly extrude box and then poly extrude, and when you give this poly extrude and when you increase the distance and individual elements, and now you can see each primitive is extruding outwards, right? So we have this structure right now, and when we inset, it is decreasing the area of the extruded face. When we extrude something, right, it creates new primitives around it, around the extruded part. Here, these are new primitives. This was extruded outwards, and when we inset this, now we are decreasing its size. And we have this option here also, spine control, and we have something like thickness scale. And many people confuse in these two options because they look like same, but they are not same. And how I am going to explain this, you see right now, give this value 1, so or 1 is was the default value. Now it means this value doesn't matter, like it has value 1, but it's the default value we have. When we extrude it, this is the default value. We haven't changed anything in this, but we have inset, we have already inset this, you can see, right? So we are decreasing the area of this. Now when you give it divisions, and let's say give something like this, right? Now we have something like this, and I would say twist this. We have this goal structure, right? And now you would see how this inset and this thickness scale are different. Okay, when I decrease its value, you see the whole extruded part is getting smaller, right? Not just this primitive area, the whole extruded part. And this is what thickness scale do, because when we inset this, we are decreasing or increasing the area of our extruded primitive. But when we increase or decrease the thickness scale, we are increasing or decreasing the thickness of the whole extruded part, not just the extruded primitive, right? I hope this is clear, and this is really important to know at this stage. So what just happened? Nothing. Okay, now just delete this, we don't need this. This was just an example. So now we have our base plane parallel to our base, right? And what we can do, we can we can check this side group, and we can delete the side group. And I already told in the last video what is side group, and I can tell again. When we extrude something, the primitives that are creating the extrude tool, creating new primitives, and those primitives are in a group, and the old primitives are in old group. So now we have two groups, and I will show you in this example when I give this a class node. And now when I turn and when I give this a base group extruded side, you see that our side group is just deleted. Side groups, it is something like you have a cube, right? You extruding this primitive, and these new primitives are side groups. This is our main group. These are side groups. So in this example, when we extruded this, right? These are extruding primitives. These are the new primitives that we are creating, right? When you just insert what was the default value? I guess it was 0, right? Yes. So when it was something like this, right? And now we are creating these new primitives. These are in this side group. So give this -1, and let's insert this something like this. Okay, it's now parallel to the plane. And now we blast this. The side group is deleted, but we need that because we need this plane. And what we can do now, I only want this one. What we can do, we can do it by manual selection, or we can do it by procedural selection. I would give each primitive island, these primitive ring, a class. Now these two have class, and I want this on the primitive level. So now when you toggle your geometry spreadsheet, you can see we have a class. And when I blast one of them, which one to blast? This is 0, this is 1. We need 0, so we will blast the 1 at the rate class 1. Now we have this, and I need alternative primitives, so I would give group by range, and every 1 out of 2 in this group, right? Perfect. And blast again. Which one? Group 1, and we have these rings. Now to create the some thickness to these, we can poly extrude again, and in this poly extrude, just extrude these downwards like distance in minus, and inset to give them some visual interest, right? And now what we can do, we can reverse, and this is our new node. And what it just did, I think you know what it just did, because if you are at this part, then you know what it did. We have our faces facing like inside, right? And now when we reverse this, we have our faces facing outwards. So now its normal is in this direction, and this perimeter normal is in this direction, right? Now we have this, and what I want to do, I want to have those supports connected to these points. So what I want to do when I poly extruded this, I want to have a side group. I only want this one. So when I blast this and when I connect this to weight, we have to directly connect this. And when I give this our group 1, sorry, extruded side, not group 1, and when I toggle this on, so when we were blasting this, and we it was like extruded, it was something like, just delete this, we will do it again. Okay, poly extrude, right? And side group, right? And blast. And when I toggling this extruded side, it is blasting everything, I think, because we have the same name here also. So it worked when I give this something else like base extruded primitives. Okay, and when I give this, so it was the name that was causing that issue. Now we have changed the name to something else, because this blast, this extrude side group also with the name, like also has had the name extruded side. And now I just give this a different name, and now we have these structures. Now I want to extrude, like I want to extract their middle points, their primitive points. What we can do, we have this extract centroid SOP, and what this do, we have primitives, right? And now we have all the primitive center point separated, right? We have all these center points. And now when I add them together, when I connect them together with this add node, we have used this add node a lot of times, like many times. So when I go to polygons and by groups, all points, right? And what we can do, we can like close them, so we can have this circular primitive with this circular curve. Now I want to share a very important thing here. We like, you have this thing in your mind, like this question, and I'm right, and you are thinking probably now, like, why we are using extract centroid, then why we are connecting them together. And I need to tell you why. Because we have separated these points to like copy our support to these points, right? And there are two ways we can just copy two points. Like, let's create our line, and in this line, you see it looks something like this. And um I want to slide the origin to the x by something like this. Point 5 is enough. And when I transform it, transform, when I transform this, and I want to create some visual interest in this also. So what I'm going to do, I can rotate this in the Z direction, something like this, and go to pivot transform, and in the Y axis you can wait -21. No, it should be positive 21, and you would see what I'm doing, something like this, and then mirror this. Now we have something like this, and when I origin, it can something like this, and go to transform and change the pivot also, something like this, and you can, it's just the values. You need something like this because we have the base, like we have to support the base with the structure, something like this. It's just visual interest. Our main focus is to know what each node do and to learn about all these nodes, right? Because these are like our base. We need these to master the basics. And when we have a big project, then we understand what each node do and what we are trying to create with them, right? This should be our goal, and this is our main goal. So we have this structure and give this sweep and round tube, square tube. We don't need columns, and you can decrease the width also. Okay, right. These are bit like very thin. We can increase the width, something like this, and single. So we have something like this, and we can separate these and go to origin. This is fine. You can do also, you can go to sweep and you can turn this, and you can wait, you can create something. It's not working because we need some more edges, but I guess this is fine. We don't need to change anything, right? And when we copy these to the curve, it will look okay, I guess. So now we have this sweep, and when I we have our points here, right? So when I copy to points, I want to copy here, I want to copy this. When I do this, we have something like this. And copy to points have one disadvantage, that we don't have additional rotations. And what additional rotations are? What if I want to rotate this on their yaw axis, which is the y axis? What do I need to do? What if I want to rotate these on that axis? So we can have some additional rotations, and copy to curves have their advantages, and we can do this also by something like this, and it won't look bad. But for your for to have for a more visually interesting geometry, we can use copy to curves. And when I select this, I want to copy to this, no, not this, because to this, and uh, when I copy the sweep to this curve which is closed, right, and we have this, and we have additional rotations in our copy to curve tool, and when you apply the yaw you can rotate them on their y-axis, and when you can have something like this, now we have some visual interest and a symmetry, right? So copy to points we can use here, but copy to curves is just a new node. And now you know what it does. We have another rotations like apply pitch. Pitch is like you have a plane and you want to rotate in this axis. This is our pitch, and when you rotate, when you want to rotate this, this is our apply roll and twist. So copy to points, it's okay. Now this is our support, so give this a null, and you can say support out, right? And what we have our base and our guardrails, and we have our support, and we have two more things which are blast, connectivity, blast, poly extrude, blast, and connectivity. But we have this also. Where is our we created that. Yes, we created, and you see when you have we didn't do it. I guess we did it. We have this, we blasted it, and we have these points. We have to reverse this. Just reverse the normals. I think we created that, right? We created the base. We didn't. It just, I guess we did. It doesn't matter. Now we can create it here also. So I think we extruded that. So this would be our base, and what I'm doing, you will understand. I know you will. No need to worry. You will understand this. Blast, and let's extrude this also. Poly extrude, and when you extrude this, you have this, and output back. Now we have this, and when we merge these two, we have something like this. This would be our base, and our support will connect to these points. Where is our support? You can merge your support here, so when you see something like this, but I want to show you something. We have an issue. Now when we copy to curve, it is copying at the middle point of this geometry, and the middle point exists here. What if I want to connect from this? We have match size, right? So just add match size and convert it here, and I want to have you see this is our geometry whose bounding box is to be matched. We can match the bounding box of another geometry to affect to affect its size and length and everything. What do I mean by that? We have a primitive ring, actually this ring, and its bounding box can affect its match size. And what do I mean by that? We can add this, and we have now this is a bounding box of this circular curve, and this is a curve but it's closed curve with geometry inside with a primitive. So when I am giving this geometry whose bounding box is to be matched, we are giving this an input to whose geometry is in the reference now, whose bounding box is in the reference now. And when I go to bounding box and I give this, I guess, minimum, not maximum. Now you see its maximum point is touching the bounding box of the centroid of the ring that we have created. It has a bounding box and we can see it here when I toggle this on and I see, or where is that? Nope, I guess here. Oops. Ooh. Where is our base? We have blasted this, I guess here. Yes, this is our circular ring and it has a bounding box, and this bounding box is going down there, and we have this, and now it's affecting the match size of this, right? And now the minimum and the maximum of this depends on this bounding box. So I have already talked about this in my import video, and I think we are done with this. So when we toggle this on, we have our base ready, our base support ready. And when we merge, we can directly merge. Okay, just directly merge this, and we have this, right? And we can have this, and our base is, where is our base? Nope, this is not a base. Where's our base? I think, yes, this is our base. See, well, now we have this. And now I already told you in this video that I would introduce a new node, and which is new node, and which is copy and transform. And what it does, we have to merge. We will copy and transform our base, our whole base, which is this base support, with this circular ring, primitive ring, extruded primitive ring also. So you can give this, and you can give this, and we will copy and transform this whole part. Copy and transform, and this node is not that difficult to understand. So we will just now we have total number of 2. We have this geometry is now copied, and they are in total 2. When I scale, now you can see we have 2. When I give this 3, we have 3, 4, 5, and so on. 2. But you see, when I scaled the second part down, it is decreasing the height also, the y direction, the height in the y direction. I don't need that, just give this one, and now we have the same height, but we have scaled down in the x and the z direction. And now when I connect this, we have our whole base. Rotate this on the y-axis, rotate the wait, rotate the second part in the y-axis. So when you rotate it, you can see something like this. We have this, and you can create 3 copies of this whole geometry, and we have something like this. And when you toggle this on, we have our whole procedural tower, right? And this is like procedural. So when you go here first, and when you increase or decrease the column, when you increase or decrease the columns, give this 40. And I want to tell you something, like when you're decreasing this, we have some like deformities in our geometry. And I want to tell you something here. This is like not totally procedural, because we have selected some parts, like not so procedurally but procedurally. For example, when we give this attribute name and attribute name 1, and we have created some expressions, and when we give these our vertical edges and these, we have selected these by angles, by edge angles. And I want to tell you something here. Let's say we have selected this edge by the max angle 32, right? What if we increase the size of this primitive? When we increase the size of this primitive, the angle is also changing, and that's what happening here. It's not perfectly procedural, but it's procedural. So if you change anything here, let's say go here, and when you do any changes in the points, you say it's procedural, right? Because the edge angle is not affecting here, but it is affecting here. When you decrease and increase the column, you see we have some deformities. We don't have now because the edge angle is right here, and we don't have, like we have here deformities, and it's now we have here. And when you give this value 40, we don't have any, and 41, no, we don't have. We have here 40, no, 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 no. So now you know what is our main motive to create this is not to create something, because we can use this, but it's not that useful piece of geometry. And yes, it is procedural, right? Don't bump your head over this. But I want to tell you something, that we are creating these projects. I have created these series to tell you the basics of this Houdini, so we can have a better and easy upcoming days, right? So I think this part is also over. We have our procedural tower, and what if I increase or decrease the height? Let's do it. It is procedural, but it will deform when we go. You can see here, but we are not going that far. So yes, it is procedural, and if you have completed this, then be proud on yourself, because you are learning the world most difficult VFX software out there. And I guess this is it for this video, and I will see you in the next one. Until then, take care.